All right, now that we have finished all of the area and perimeter business dealing with flat two-dimensional shapes, now we're going to switch over into the world of three-dimensional shapes and talk about volume, and then that is followed by surface area in our unit. All right, so we're going to start with the volume formulas first, and we're only going to focus on two specific families at the first point. We're going to do all of the prisms and the cylinders together first, and then we'll talk about the other two families on another day. All right, but before we do any of the formula-based stuff or look at any of these shapes, the first thing I want you to understand is what volume is about. All right, volume is the amount that it takes to fill up a three-dimensional figure. So you are filling up the inside of a container, basically, is what's happening with volume. All right, so area was covering the surface of it, okay, and perimeter was going around the outer edges. Now volume is going to fill up the inside of a three-dimensional shape. All right, and if you look on your formula sheet, you'll see that there are two types of prisms. There's the rectangular prism and the triangular one, and then there's the cylinder. So those are the three shapes we're going to really practice with here. I'm going to do some examples of all of them, and then I will tell you which ones you need to complete on your own for homework credit. All right, so for this first one, we're looking at a rectangular prism because the sides are rectangles and the top and bottom is a rectangle. That's how you know. Okay. For all volume formulas, basically when you fill up a container, you are filling up the bottom of the shape and then its height is rising afterwards. It always fills up the bottom first, right? So if you think about it in this box right here, it's going to fill up this bottom rectangle first, and then it's going to rise the height of the box. And that's where the formula comes from, right? You can do any volume formula by using area of the base, which is what this capital B stands for right here, and that's on your formula sheet in the index section down at the bottom, right? But this is area of the base for capital B. It's not just the base number, it's the whole area of it, right? And then you take that area of the base and you multiply times its height and you'll always get the volume. But if you look specifically for the rectangular prism on your formula sheet, it gives you a different formula, but the formula works itself out the same. Because the formula for a rectangle is length times width, that's your area of the base right there. That's that big B component. Then you're going to fill up the height of the box, and that's where the H comes from. So on your formula sheet, all you see is LWH, because length times width times height does exactly what area of the base times height will have you do in this shape. Right? Now remember, we've talked about this already once before, that your length is your left to right number. Your width is going to be your front to back, or your side piece, and then the height is the up and down. So you want to make sure that you're getting the numbers in the correct spot for the correct letters, because as our formulas start getting longer, you're going to see different things in different places for the L, W, and H, and if you don't put it in the right spot, it will affect your math. For this one, you can kind of get away with it and mixing them up, but it'll give you the right answer, but in future problems it won't. So you might as well train yourself now to put them in the right spot at the right time. So looking at our shape, the left to right number is right here in front of you. If this is the front of your box, then the 8 is your length. So in the formula, we're going to take and do 8, okay, and then this area over here is not area, we're finding volume now, so I'll change that to a V now. All right, and then the W is the width or the side piece, that would be the 5. Okay, and the height is how tall the box is. The box is 4 centimeters tall. All right, so there's the correct placement of the numbers. So when you take and type in 8 times 5, that makes 40. 40 times 4 makes 160. So for this box, it will hold 160 centimeters. And now the unit does change a little bit. It doesn't get a little 2 in the air. Now it gets a 3. All volume is cubed, right? And the little silly trick behind saying that is a rhyming word. V rhymes with 3. So if you're finding the V, you need a 3 in your final answer. Okay, so see if that'll help you remember which one to put, because if you don't have that number there in the air, your units are technically wrong. All right, so that's how you do a rectangular prism. All right, so let's switch down below to the cylinder. Okay, and if you look on your formula sheet, right, the volume for a cylinder is pi r squared h. Well, if I go back to the whole area of the base times the height, this pi r squared is the area of your circle. And in this shape, it's going to fill up the circle first before it rises in height, right? So that's where the formula comes from, right? So let's fill in our pieces. We know pi is always 3.14. The radius is given in the picture. It's pointing to the 5, so that's 5 squared. And the height of the whole cylinder is 25. So this is a very tall cylinder. Mathematically, you have to go through PEMDAS, so you have to do exponents first. 5 squared turns into 25. So now you can go ahead and calculate 25 times 25 times 3.14, right? And we're going to round to the tenths place anytime we're getting these decimals, right? So the volume of this cylinder, or the amount of stuff it will hold on the inside, is 1,962.5 feet cubed, which is a lot of stuff, but it's a tall cylinder, so it's going to hold a lot more. All right, so let's go down here in the bottom section. We're going to take and work through all of these examples together, right? And then I will do one more from the back side, and then the rest will be yours for homework purposes. All right, let's go ahead and take on number 3 first, because that's a shape that we haven't quite done yet. We've done the other shapes, though. 3 and 6 are the same type of shape. You'll notice they are the same shape, but they're laying in 2 different positions. Number 3 is standing up on its triangle base. Number 6 is laying down, so the base is not that rectangle it's laying down on. Remember that in order to name a prism, you name it based on the 2 bases that you have, and you have to have 2 of them. All right, so you can't call number 6 a rectangular prism because it's only got 1 rectangle on the bottom. It doesn't have a top rectangle, so it only has the 2 triangles. That's your ceiling and your floor if you look at it that way. All right, so looking at number 3 and number 6, they are both triangular prisms. So when you go to your formula sheet, all you're going to see on your formula sheet is volume equals big B times H, which works for everything, like I've been saying. But the big B, you have to calculate the area of the base. Well, the area of the base on this triangular prism is a triangle. And it doesn't matter if you use the top triangle or the bottom triangle, they're exactly the same, right? So pick one of the triangles, and now you have to find that area before you can actually use the rest of the formula. So now you go back to what we've been doing for the past couple weeks, and you find the area of a triangle, which is 1/2 little b little h. Just using the triangle, don't look at anything else in the picture, right? The area of the base, or should I say the base of that triangle, is the 5. The height of that triangle is the 11. So now you have to figure out this whole calculation before you can even go find the volume of this shape. 5 times 11 is 55. If you take half of 55, you get 27.5. This 27.5 is your big B. That is the area of the base. So now you're ready to do volume equals, and you're going to insert 27.5. And now you want the height. This height is the height of the entire prism from top triangle to bottom triangle. It always connects the 2 bases, or in this case, the 2 triangles. So for this picture, it's the 10. That's how tall this triangular prism is. Right, so 27.5 times 10 is going to give you a volume of 275, and we're doing yards, and because it's volume, we need a 3. So 275 yards cubed. All right, so this formula tends to be a little different because you have to find the area of a triangle before you can even go calculate the volume. None of the other formulas have you doing that separate conversion. It's all built into its formula. All right, so let's go back over to 1 and 2, and then we'll do the bottom row. All right, for number 1, you have a rectangular prism, so we're back to volume equals length times width times height. Nothing fancy there. The length number, remember, is left to right, so that's 9. The width number would be your side number, which is 2, and the height of this thing is 6. So you straight up multiply 9 times 2 times 6, and you should get an answer of 108 inches cubed. All right, those are one of the easiest shapes to do. Okay, so be very careful and make sure you don't mess them up. All right, while we're doing that same formula, let's go ahead and go down to number 4 and do the same piece. It's the same shape, just a different size shape, and it's turned a little differently, but it's still a rectangular prism. So length times width times height. The length is 11 from left to right. The width would be the side piece, which would be a 3, and the height would be a 3, how tall it is. 11 times 3 times 3 is going to give you 99, and the mm stands for millimeters cubed. All right, 2 and 5 are both cylinders, so we're going to go ahead and use the cylinder formula for both of them. And that would be pi r squared h, right? And that's going to work for both problems here. All right, so in the first one, we know pi is 3.14. That's no surprise. Okay, now be careful because this cylinder is laying down on its side. That doesn't mean it's harder to read or it's going to have anything different. It's just laying down. Radius is 4. That's the part of the circle you can see that they've pointed to. And the height. The height is how tall the cylinder is if it were standing up. Or another way you can look at it is it connects the two circles together. Right? The height will always be the connecting piece between your two bases. Right? So in this case, the height would be 12. Right? So mathematically, we have to do 4 squared first, which turns into 16. And now you want to calculate 16 times 12 times 3.14. And again, we are rounding to the tenths place when we get these decimals. You should have come up with 602.9 meters cubed. Okay, so it's very important that you put the numbers in the right spot in the formula, but that you also use them correctly when you're calculating. All right, for number 5, same formula, same type of shape, just different values, different sized cylinder, and it's standing up, not laying down. So pi would be 3.14. The radius is 6.3. Now notice all of these cylinders that I've worked out with you have given you the radius. If they happen to give you the diameter, you have to cut it in half. Okay, and then the height of this one is 9. Right, so in your calculator, you would start with the 6.3 squared, leave that number on your screen, and then do times 9 times 3.14. Right, and when you come out with an answer, it should be 1,121.6 feet cubed. If you don't get that and you're trying to use the same number as I am, then I need to look at how you're typing things in the calculator because something's not coming out right. All right, number 6 is another one of those triangular prisms. It's just not laying on its triangles, it's laying on its side. Right? So you're still going to use V equals big B times H. Well, the big B part, you've got to come off to the side and figure it out. It's a triangle. Okay? These triangles right here on the ends, those are your bases. Okay, even though it's not sitting on them doesn't mean that the bases have got to be two of the exact same shape that you've got sitting in your shape. All right, so for this piece, we're going to have to do area of a triangle first, 1/2 little b little h, and only look at the triangle numbers. So because the numbers are on the left side, that's the only triangle I'm going to use. I'm not going to use the bottom one. All right, so the triangle base is 4.1, and the height of the triangle is 5.8. Right, so in your calculator, do 4.1 times 5.8, and then either divide by 2 or multiply by 0.5, whichever way you go through this. Right, and you should come out with 11.89. That value right there is going to go in the big B spot of your volume formula. So now that you have the big B, we can continue with the problem. So volume equals 11.89 times how tall the thing is. Remember, the height connects the two triangles together, connects the two bases. So in this problem, even though it's laying down, this 7 connects those two triangles together, and that's your height. So this 7 is going to be the h in the volume formula. Okay, so be very careful with this. You've got to take each piece separately and do things slowly. Then you take 11.89 times 7 and round it off to the tenths place, and you should get 83.2 meters cubed. Okay, so there's all those on the front to use as examples and hopefully get you through doing the basics on the back to where you can understand what you're doing. All right, if you flip it over to the back, I am going to do one more problem with you, and that's the one at the very, very bottom. Okay, you see that you have pictures at the top and you have even words that tell you which shape it is and what your pieces are. When you get to this word altitude, altitude is another word for height. Right? It's another word for height of a triangle. Okay, so don't be afraid of that word, but that's actually the height of a triangle. All right, now the one I'm going to do with you is number 13. I'm going to let you try all the other ones and come to class with any questions you may have and see how well you do. But for number 13, these bottom 3 shapes are what are known as complex figures because just like in complex area, we have to do more than one formula and add them together to get the total volume. Right? So it's the same idea, but you've got 2 different 3-dimensional shapes happening at the same time. So in number 13, our 2 shapes are a rectangular prism, that's the whole bottom part, and then the top is half of a cylinder. It's not called a semi-cylinder, it's just called half of a cylinder. Right? So those are the 2 formulas that we want to take and calculate the volume for to get our final answer. And again, we're looking for total volume in this bottom section. Okay, so you're not finished until you know what both volumes are together and you've added them together. All right, so for the first one, let's start with the easy part, and that's the length times width times height. That would be your box on the bottom, right? And the length number would be 12. That's the left to right number. The width would be the side of it, which is the 6, and the height would be the 5. Okay, so just by doing 12 times 6 times 5, we're going to get 360 meters cubed. And that's just the volume of the box on the bottom. Now we need to do the volume of the half a cylinder sitting on top, right? And when you do a cylinder, you're going to take the volume of a cylinder formula, which is pi r squared h, but that's for a whole cylinder. So anytime we want half of something, we're going to throw a 1/2 in front of it, and that'll cut it in half. So you're going to do the same operations you would normally do, but then at the end, you're going to take half of that number. So you have 3.14, and then the radius, right, is the 3 that it's pointing to, 3 squared. Now the height of it is the height of the whole cylinder. So you have to kind of, in your mind, tilt the cylinder to where it's sitting on a circle or connect the two circle pieces. This is the height of the cylinder right here, the part that connects your two circle pieces, right? And that number is a 12, right? Because you can see it from the box on the bottom. So that's the height of the cylinder there. All right, so now you go through in your calculations. 3 squared is 9. You have to do that part first. Now do 3.14 times 9 times 12, and then you can either cut that in half or you can times by 0.5. You should get 169.6 meters cubed off of that, though. Right? And you still don't have a final answer yet, because the whole point of doing this one problem is to get the total volume for this entire shape. Right? So now that we have our individual pieces, we're just going to add the two together. You're going to add 360 and 169.6. So 360 plus 169.6 is going to give us a total volume for this shape of 529.6 meters cubed. Right? So when you go to do numbers 12 and 14, this is what you're going to have to do. You're going to have to do two separate shapes first and add their volumes together, right? Just like we did with composite figures. All right, so your job is to complete all the problems on this back side that I did not do with you and come to class with answers ready to check and see what volume questions you have from this group of shapes.